In this unit, we will learn basic data types, variables and arrays. We will also discuss primitive data types like byte, short, int, long, char, float, double, and Boolean. We will create and discuss different types of variables and arrays. Write programs to search arrays and learn references and reference parameters. After completing this unit, you will be able to understand primitive data types used in Java, their size and range of acceptable values, different types of variables, one-dimensional and multidimensional arrays, strongly typed nature of Java, searching arrays for different data types, references and reference parameters. Let us start with our first topic, primitive data types in Java. There are 8 primitive or simple data types in Java. These are grouped into integral data types, floating point data types, character data types, and Boolean data types. Integral data types are used to hold signed positive and negative whole numbers. These contain byte, short, int, and long. The difference between these data types is the amount of storage and the range of values that they can store. These are further discussed in the subsections. Floating point data types can hold whole numbers as well as fractional numbers. There are 2 floating types, float and double. Floating point numbers are also called real numbers. These are further discussed in the subsections. Character data types is used to store letters and numbers in Unicode format. For example, char ch declares a variable of character data type. All these data types are further discussed in the subsections. Boolean data type is declared by Boolean keyword. Boolean variable can store true or false value. Simple data types are used to represent single values but not objects. Java also defines integer, float, string, and Boolean classes. These are called wrapper classes. This list shows wrapper classes for each simple data type. These classes wrap or encapsulate simple data types in a class object. These constructors show how wrapper classes wrap simple data type. We will discuss constructors in detail when we will discuss classes. Here are some examples of constructors. Now we will discuss each primitive data type in detail. Let us start with byte. This is the smallest integral data type. It can store signed whole numbers. It uses 8 bits to represent a value. The range of values it can contain is from -128 to +127. Byte variables are declared by using byte keyword. For example, byte b declares a byte variable b. Let us see a simple program that demonstrates strongly typed nature of Java. This program will generate compilation error at line number 12. In the statement b equal to b plus 3, 2 operands on right side are byte and integer. Java makes calculations on integers. Here 3 is integer but b is byte, and the result is an integer when we try to assign this value to b. An error is generated for possible loss of precision. This is because of strongly typed nature of Java. To correct this error, replace statement with now the result of b plus 3 will be an integer value, that is 123, and it will be converted into byte and then stored in b on left side. Braces are important here. Next integral data type is short. Short variable can store signed positive and negative whole numbers. The size of short variable is 16 bits. A short variable can store values in the range from -32768 to 32767. It is mostly used in those machines that support 16-bit word size. Word size is the amount of bits that are fetched and processed by a CPU at a unit of time, for example, a microsecond. 8386 microprocessor was 16-bit processor. In this program, we have declared a short variable at line 7 and assigned initial value of 32767. This is the maximum value that a short variable can store. At line 8, we have used a post increment operator that adds 1 to short variable s. Arithmetically, the value of short must become plus 32768, but it is minus 32768. This is due to range of short variable because a short variable can hold values only in its range. In this program, line 8 would not work and generate a compilation error. The correction is made in line 9. At line 9 of this program, addition is performed by converting the numbers into integers, and the result exceeds the valid range of short. So we have to convert the resulting integer back to short. This is done by casting. General form of casting is like shown in this figure. Here, target variable will hold the result of the expression. Data type is the type in which the result of expression is to be converted. Data type is the type of target variable. Next integral data type is int. Int is commonly used data type to store signed whole numbers. It occupies 32 bits. The range of values stored in an integer is from -2 power 32 to 2 power 32 minus 1. Integer variables are used to control repetitive loops and can be used as indexes in array operations. Java uses integers to make calculations. If you are using short or byte variables for calculations, Java promotes these types into int internally. For example, look at this example. You have to explicitly convert the integer 5 resulting from the second statement. Last of integral data types is long. It is the largest of all integral data type. The size of long is 64 bits. The range of values that can be stored in long variables is from -2 power 64 to 2 power 64 minus 1. It can hold signed whole numbers. Long is used in computations where very large numbers are required. Finally, let us see the behavior of integral data types in arrays. In arrays, the behavior of byte, short, and int is predictable. Byte uses only 1 byte per array element. Short uses 2 bytes per array element, and int use 4 bytes per array element. Java runtime environment uses the size of a variable as required by the computer in use. Some implementation of Java Virtual Machine store byte and short variables as 32 bits rather than actual size of 8 bits and 16 bits. Next category of data types is floating point data types. There are 2 floating point data types in Java, that is float and double. Both of these types are used to hold signed numbers with fractional part, but they differ in amount of storage. These are also known as real numbers. These are used in calculations such as scientific and mathematical functions like sine, cosine, and square root. Now we will discuss each of floating data types in detail. First floating point data type is float. Float is used to hold signed numbers with fractional part, for example 2.0 and 13.57. It specifies a single precision value. Single precision values consume less space on machine and are faster than double precision values. Float becomes imprecise when the number is very small or very large. Float variables are used when you are using fractional numbers but not need a high degree of accuracy. For example, floats is useful when you are representing currency like Pak rupees and US dollars. Float variables can be used for tax and pay calculations. Second floating point data type is double. This is used to represent very small or very large fractional numbers. It requires 64 bits to store a number. It is faster than single precision on some computers that perform optimized mathematical calculations. Double has the highest accuracy when you are using very large or very small fractional numbers. It is important to note that all mathematical functions like sine, cos, and square root return double values. Double maintains accuracy in looping and iterative calculations. Next category of data type is character data type. It has only one data type, that is char. Characters are stored in variables of char data type. Char data type can hold only single character. Java uses Unicode to represent characters in Unicode format. Any character in the human languages like Arabic, Greek, Latin can be represented in Unicode. It requires 16 bits to represent a single character. The range of char is 0 to 65536. The range of ASCII characters is from 0 to 127 and ABCDIC is from 0 to 255. But Java can handle Unicode characters in the range of 0 to 65536. Characters of English, German, Spanish, and French can be stored within 8 bits range. Here is a declaration and an assignment statement that declares a character variable and assigns a value to it. Arithmetic operators can be applied on character variables, and these behave like integer arithmetic. For example, look at these two statements. First statement stores a character to ch, and second statement increments the value of ch. You can assign a whole number to a character variable. Java will treat it as ASCII or Unicode value. For example, this statement stores a in ch. To assign character value to character variables, enclose it in single quote. Only one symbol can be stored in a character variable. Now we will discuss a few programming examples. At line 5 of this program, we have declared two character variables C1 and C2. At line 6, C1 is assigned ASCII value. This is ASCII code for alphabet A. At line 7, we have assigned character B to C2. You can assign only single letter to a character variable. Line 8 and 9 print the values stored in these variables. In this program, the arithmetic statement is different from those of unary pre, post, increment operator and addition assignment operator. At line 8, the arithmetic statement is adding a character variable and an integer. Java performs arithmetic operations in integers. It converts ch into integer before adding 10 to it. The resulting value is an integer. This needs to be converted back to character. This is done by using cast operator that converts the result into target data type. In this case, we used char to convert the result into character and assigned the result to character variable ch. The last data type in this topic is Boolean data type. Logical values are stored in Boolean data type variables. There are only two Boolean values, true or false. Boolean data type is used in conditional expressions like if, for, and do while. All relational operators return true or false value. Now let us discuss a program that demonstrates the use of Boolean value true. At line 5, if conditional statements tests a Boolean value. Since this is true, the statement at line 6 is executed. We will discuss control structures including if later in detail. For simplicity, remember that if the condition in if statement at line 5 returns true, only then the next statement is executed. General form of if condition is, another general form of if is. Here, if condition is true, then both statement 1 and statement 2 will be executed. You may add many statements in this block. Now let us see the program that demonstrates the use of Boolean false value. When Java conditional statement returns a false value at line 5, the statement at line 6 is not executed and nothing is printed. Now let us see another program that uses a relational expression and returns a Boolean value. At line 5, a relational expression is given as an argument to print method. Since the number 10 is greater than 9 and this relational expression returns true Boolean value, this program will print true. It is important to note that only Boolean values true and false are sufficient to control if, while and do-while statements. Now we will discuss literal values used in Java. Constant values are called literals in Java. Java contains 4 types of literals. These are integer literals, floating point literals, Boolean literals, and character literals. Integer literals are whole number values are integer literals. Java has decimal, octal, and hexadecimal integer literals. This picture shows some literals. Floating point literals represent decimal values with fractional component. These are represented in standard or scientific notation. For example, 3.0, 3.14159, 0.668 represent valid standard notation. These can also be written in scientific notations. Floating point literals in Java have double precision. Capital F or small f is appended in the last of the constant to specify a float literal. Float type needs 32 bits while double needs 64 bits. To specify a double literal, append capital D or small d to the constant. Next type of literals are Boolean literals. These can have only 2 logical values, that is true or false. True value is not equal to numerical value 1 and false is not equal to number 0. True and false values can be assigned to variables declared as Boolean. True and false are case sensitive and true or false are not logical values in Java. Java also contains character literals. Character literal is enclosed inside single quotes. It requires 16-bit storage. Escape sequences can be used to write special character literals. This table shows some escape sequence characters, their purpose and print statements that can be used to print these escape sequences. Last type of literals are string literals. String literals are enclosed in double quotes. All escape sequences defined for character literals also work for string literals. Strings are treated as objects in Java. Do not split strings on multiple lines because there is no continuation character in Java. This table shows some string literals, Java statements, and their output. Now we will discuss arrays. Collection of similar data types is called an array. Arrays can be single-dimensional or multidimensional. Single-dimensional arrays are like linear lists. Multidimensional arrays are like matrix. Each array has a unique name and array index to access each value stored in array elements. Array index is an integer number like 0, 1, 2, 3, 4, and so on. Arrays can be used to store simple data types like integers, floating point numbers, character constants, or objects. To store a value, you have to create an array of that data type. If you want to store integer values, you have to create an array of int data type. To store real numbers, you need to create an array of float data type, and similarly char array for characters. To store objects, you have to create array of that data type. Now let us discuss one-dimensional arrays in detail. A one-dimensional array is a linear list of similar type of variables. Creating an array involves two steps. First step is to declare an array, and second step is to allocate memory to store elements in that array. General form of declaring a one-dimensional array is data type followed by array name and set square brackets. Here, data type specifies the type of values that are to be stored in the array. It can be a primitive data type like char, int, byte, float, or some object type, for example, string. Here, array name is a user-defined name that follows naming rules in Java. Next step is to allocate memory for this array. General form to allocate memory for this array is, here, size is the size of array. It specifies total number of elements that this array will contain. This must be a whole number. The keyword new is used to allocate memory dynamically. These two statements can be combined into one like this. One-dimensional arrays can also be created by using this general form. Arrays can be automatically created without using new keyword. The general form to create arrays automatically is. Now let us discuss a one-dimensional array named ArrayName. This figure shows an integer array that contains 3 integer values. These are stored at neighboring memory locations. Each element can be accessed by using ArrayName followed by index value in square brackets. For example, the value at index 2 is 6435. This is accessed by name of array followed by 2 enclosed in the square braces. Let us see a simple program that creates an array and uses for repetition loop to print the contents of this array. Line 6 declares an integer variable that will be used to store array index. Line 7 starts with string class name and declares an array of strings named names. This array contains 3 names, Ahmed, Saba, and Mona. Line 10 starts with a for loop. For loop will be discussed in detail when we will discuss repetition control structures in Unit 3. The general form of for loop is for keyword followed by left space, followed by comma, separated initialization statement, condition, iteration statement, followed by closing brace, followed by a statement or block of statements. Let us see the for loop execution step by step. In the first step, when for loop starts execution, the initialization statement is executed, and it initializes the repetition control variable. In this example, we are using I as a repetition control variable, and it is initialized to 0. I is initialized to 0 because array indexes start from 0. In second step, the condition is evaluated. This condition returns a true or false value. The condition tests the loop control variable against a target value. In this example, we are testing it against 2. And now the value of I is 0 and the condition expression will return true. Third step is to execute the body of loop if the condition is true. Since the condition is true, line 11 will print the value stored at 0 location of names array. When the condition expression returns false, the loop terminates. In the next step, after executing line 11, the control moves to line 10 at iteration portion, that is I++. This expression adds 1 to the value of I, and now value of I is 1. The condition is evaluated again. In this case, it will test 1 is less than or equal to 2. The condition expression returns true, and the statement at line 11 is executed again. The control moves to iteration statement at line 10, that is I++. The value in the control variable I becomes 2. The condition is tested again. Since it is true, the statement at line 11 is executed. Again, the control moves to iteration statement at line 10. Now the value of I is 3 and condition becomes false and loop terminates. There are no more statements in the program, so program terminates successfully. Conceptually, this array will be stored in memory as shown in this figure. Now let's talk about how Java ensures boundary checks of an array during program execution. At runtime, Java checks that the program does not access array elements that are out of bound of array index. If index value is out of valid range of array size, then an error is generated at runtime. Last line in this output shows the error message that will be generated at runtime. This is because of accessing array element that is out of bound. Valid array indexes are names 0, names 1, names 2. This program tries to access names 3, that is invalid, so exception or error occurs. The error message also shows line number of the code that has generated the error. Now we will learn references and reference parameters. Two ways to pass an argument to a method are call by value and call by reference. Other languages allow you to choose between call by value or call by reference, but Java does not allow to do so. In Java, all primitive or simple data type variables are passed by value and all objects are passed by reference. That is, a reference to an object is passed to the called method. It is important to understand the difference between both call by value and call by reference. Here is a comparison. In call by value, simple data type variables are passed by value. In call by reference, reference to object is passed. In call by value, a copy of the variable is made and sent to the called method. In call by reference, reference to the object is sent to the called method instead of a new copy of the object argument. In call by value, changes made to the parameter in the called method do not affect actual variable. In call by reference, changes will affect the source object because its reference points to same memory location even in the called method. Since a new copy is created, system resources are required to make, and this is an overhead in case of large number of parameter passing. Arrays are treated as objects in Java, and reference to the array is passed to the called method. This does not use much resource of system. Primitive data types are always returned by value. Objects are always returned by reference. Let us see a simple example that illustrates argument passing. This program defines two classes. Line 1 starts with the definition of my class and line 15 starts with the definition of by reference class. The program starts execution from line 19 and creates an object of my class. The values passed in the constructor of my class are 10 and 20. These are integer literals and are passed by value. The constructor at line 4 creates the object and assigns these values to the instance variables of objActual. Line 20 prints the values of these instance variables. These are 10 and 20. Line 21 calls willChange method and passes the reference of the object in the method call. At line 9, willChange receives the reference in the object obj of my class type. Inside the method, both instance variables are incremented by 2. Since there are no more statements in these method and control is transferred to line 22 right after the call to method, this line prints the values of instance variables. Now see that the values of actual object have changed. This is because Java always passes objects by reference, and any changes made to them in called method will directly affect the actual object. Now we will learn searching arrays. You can search for a specific item in an array. Searching involves comparing the required item with all the values in the array. For example, if we have an integer array containing 10 values as given in this figure, and we want to search 690 in this array and print the position of that element, then we have to compare each value in the array elements with 690. Now let us see the program that completes this task. This program declares an integer array that contains 10 numbers. Line 7 declares an integer variable that will control for loop, and we will use its value as array index. Line 8 declares a Boolean variable that contains false value. This variable tells us that the search is not successful yet, and if the number is found in the array, it will be assigned a true Boolean value at line 14. Line 9 declares a variable that holds the number to be searched in this array. Line 10 contains a for statement that repeats the block of code starting at line 11 for 10 times. If statement at line 12 compares value in each array element with the number in the search item, that is 690. If the number in the array matches with the number stored in search item, it executes the block of code starting from line 13. Inside this block, break statement is used. When a break statement is encountered in a for loop, the loop is terminated and the control moves to the statement written immediately after the block. In this program, the value is found in the array at position 5, so the block of code is executed and the message is printed. And then break statement terminates the for loop and control moves to line 19. If the element is found, the variable found contains true value. Line 19 uses an if statement that applies a not operator on Boolean variable. This operator reverses the value stored in the Boolean variable. That is, if the Boolean variable contains a true, then this statement will reverse it to false and the statement at line 20 would not be executed. If the value of found variable is false, the not operator in line 19 reverses the value of found to true, and the statement at line 20 is executed and displays the message. In this program, the array defined at line 6 contains the number 690, so the statement at line 14 assigns true value to Boolean variable found, and when line 19 is executed, the if condition evaluates to false and line 20 is not executed. Now we will discuss multidimensional arrays. These are arrays of arrays. Conceptually, these look like matrices, but these can have uneven shapes. General form to declare a two-dimensional array is data type followed by 2D, array name, and square brackets terminated by semicolon. To assign physical memory, we use this form. Here, data type can be basic data type or some object data type. Row specifies total number of rows in the array. Column specifies total number of columns in the array. These statements can be combined into one statement like given in this picture. This statement created a matrix that contains 3 rows and 2 columns. Now let us see conceptual representation of different arrays in memory. This picture shows a conceptual diagram of two-dimensional array that has 3 rows and 2 columns. Left indexes are row index and right index are column indexes. Element of this 2D array can be accessed by specifying the name of array and the index position. This is an odd-shaped array. First row contains 1 column, second row contains 2 columns, and third row contains 3 columns. Array names and index positions given in this picture can be used to access specific array element. Let us discuss a simple program that manipulates a two-dimensional row. This program declares a two-dimensional array, assigns values to each element of array, and then prints the contents of this array. Line 6 declares an array that will contain character values. The name of array is 2D. It has 4 rows and 5 columns. Line 7 declares 2 integer variables that will be used to control loop, and these will also help us to store index position of array elements. By using these variables, we will access individual elements of the array. Line 8 declares and initializes a character variable with the character A. Line 9 is a nested for statement. For statement at line 9 controls the row index of the array, and the for statement at line 10 controls the column index of the array. The for loop at line 10 has a block of code that contains 2 statements. Line 12 assigns the value stored in character variable C to array elements. Line 13 uses post increment operator to store ASCII code for next character in the variable C. The for loop at line 9 executes 4 times, and each time the inner loop at line 10 executes for 5 times. These iterations may conceptually look like this. The for loop at line 9 repeats the statement for 4 times, and when the value of I is 4, the condition in for loop at line 9 returns false. Due to this, for loop terminates. Now we will discuss multidimensional arrays. These are arrays of arrays. Conceptually, these look like matrices, but these can have uneven shapes. General form to declare a two-dimensional array is data type followed by 2D, array name, and square brackets terminated by semicolon. To assign physical memory, we use this form. Here, data type can be basic data type or some object data type. Row specifies total number of rows in the array. Column specifies total number of columns in the array. These statements can be combined into one statement like given in this picture. This statement created a matrix that contains 3 rows and 2 columns. Now let us see conceptual representation of different arrays in memory. This picture shows a conceptual diagram of two-dimensional array that has 3 rows and 2 columns. Left indexes are row index and right index are column indexes. Element of this 2D array can be accessed by specifying the name of array and the index position. This is an odd-shaped array. First row contains 1 column, second row contains 2 columns, and third row contains 3 columns. Array names and index positions given in this picture can be used to access specific array element. Let us discuss a simple program that manipulates a two-dimensional row. This program declares a two-dimensional array, assigns values to each element of array, and then prints the contents of this array. Line 6 declares an array that will contain character values. The name of array is 2D. It has 4 rows and 5 columns. Line 7 declares 2 integer variables that will be used to control loop, and these will also help us to store index position of array elements. By using these variables, we will access individual elements of the array. Line 8 declares and initializes a character variable with the character A. Line 9 is a nested for statement. For statement at line 9 controls the row index of the array, and the for statement at line 10 controls the column index of the array. The for loop at line 10 has a block of code that contains 2 statements. Line 12 assigns the value stored in character variable C to array elements. Line 13 uses post increment operator to store ASCII code for next character in the variable C. The for loop at line 9 executes 4 times, and each time the inner loop at line 10 executes for 5 times. These iterations may conceptually look like this. The for loop at line 9 repeats the statement for 4 times, and when the value of I is 4, the condition in for loop at line 9 returns false. Due to this, for loop terminates. and next statement at line 15 is executed. Line 15 is also a nested for loop, and it has more than one statements in the block that starts at line 16 and ends at line 20. It is important to note that each time inner for loop at line 17 completes, the statement at line 19 is executed once, because this is enclosed in the block of for loop that starts at line 15.